that's kind of it for the main portion of this lecture. There's not going to be another quiz, but I just want to show you some more pieces in what would be of kind of a full web stack for a major website that we haven't really talked about yet. So we spent a lot of time in this lecture talking about the app servers and databases and cache and the relationship between all of these things. We also mentioned briefly a load balancer. There's some more pieces in here that a large website may have. So right now, requests go from the load balancer to the app servers, who then go to the DBs or to the cache. What if we get so much traffic that one load balancer can't handle it? Well, then we can add a second load balancer. But what load balances the load balancer? Well, generally you do something called DNS Round Robin. And what this means is DNS is the system that converts a domain name into an IP address, and that generally doesn't happen on your machines, or that's cached all over the internet. There are DNS machines all over the internet that all cache each other's information. So what you would do is you would give a website like udacity.com, instead of mapping to one IP, it may map to multiple IPs, one for each load balancer, and then different machines in different parts of the world or different times of day or on different requests might get sent to different load balancers. And that's one way at a very, very high level to spread huge amounts of traffic across multiple load balancers. Another thing you may have either behind your load balancers or in front of them is another cache. And this is like basically just an HTML cache. And this cache may intercept requests before they even get to the app server. And this may cache HTML and images, all sorts of stuff that we know are not going to change for this user. Say it's a request comes in with no cookies, so we know the user isn't logged in. We don't have to do any dynamic requests. We don't have to do anything special. Well, we can just cache the entire result of the page. All of the HTML we're going to return, not just the database query. Some examples of this technology are Varnish is a really popular one. We use this at Reddit and Hitmonk. It's really nice. Squid is another one. And a lot of people build their own because if you're at this scale, there's a high likelihood that you need a custom solution here. But you can have basically more caches in front of your app server. Another thing you can do is use what's called a CDN. And say you've got the whole internet here. And a CDN is basically a content delivery network. And these are usually third-party companies that you would pay to cache your content all over the internet. So they would intercept your DNS requests. They'll have machines all over the world. You basically have your DNS instead of pointing at your load balancers, point at the CDN, and it may point at maybe do some round robin thing to different machines and that sort of thing. But basically, these machines are just big caches, just kind of like this Varnish cache here, that say, okay, before I even send the request to my customer, do I already have it cached? And these are just they're basically just a big cache. So the name of the game is caching. And the question is, at what level do you cache? And we've only been talking about caching DB requests, but you can also cache, entire responses, or you can pay somebody else to cache the entire response all over the internet. And a lot of the biggest websites do this. Reddit pays a third-party company to do so. Facebook and Google have data centers all over the world, and so they do it themselves. But as you grow and grow and grow, the challenge is, how much of this content actually is different on every request and how much is the same. And content that is the same can be cached, and you push that cache further and further away from you and closer to your customer to get higher and higher speeds. And when the content can't be cached, you need to add lots of app servers and internal caches and internal, custom systems for dealing with this type of load. So that's kind of how the whole picture may look, once you're at a huge scale. So I hope you enjoyed this lecture. A lot of the stuff in this lecture I kind of learned the hard way on Reddit, doing, starting with one machine and then two machines and splitting apart the services and all of that. We made a lot of mistakes along the way. And actually in Unit 7 is when I'll talk specifically about the process we went through of going from one machine to many machines as we were growing.